I have the privilege of chairing a session with 3 distinguished scholars, and I'm also very happy to chair the second session this afternoon with a majority of women. We haven't seen that. I haven't seen this so often this week, so I'm very pleased. And what kind of women? Really great women and also a great man. We will be hearing Olivia Mitchell, who is a professor at the Wharton School at the University of Pennsylvania. She's somebody I don't need to present to you. She's been working on pensions for very long time and has been one of the mothers of financial literacy. We will have Javier Olivera, who is a researcher at the Luxembourg Institute of Socio-Economic Research. He is also a professor at the Pontificia Universidad Católica del Perú and an affiliated researcher at the Department of Economics at KU Leuven. And last but not least, Brigitte Madrian. Again, she is very well known for her work on pension, especially behavioral economics aspects of choosing pension products. She is now the Dean at the BYU Marriott School of Business at the Brigham Young University. I had to look that up, I must admit. It's obviously the school she graduated from as an undergraduate. She has been at the Harvard Kennedy School before for many years. So with not much ado, I'd like to hand over the microphone to Olivia Mitchell. How persistent low expected returns after alter optimal life cycle saving, investment, and retirement behavior. Olivia.
Thank you very much. It's a pleasure to be here with you all. And for those of you that have been here from the beginning, that's terrific. For those of you that are just joining us, welcome. And without further ado, let me talk about the work that I've been doing with 2 colleagues from Goethe University in Frankfurt, Vanya Horneff and Raymond Maurer. And what we were driven by is the question, what's happening now that we're living in this new normal of very low expected returns? What is that going to do to pension saving, pension decumulation, investment behavior, retirement behavior, etc. So what we started out to do was to think about the reality of long-term low interest rates. Nominal bond yields have been below 2% in the US for some time. In fact, real yields are negative, and the same is true in many EU countries. And so the question is, how is this going to affect the financial decisions of private households in terms of their saving, investment, claiming of Social Security benefits? And what we do is design a micro life cycle model to try to answer these questions. Now, we set the stage in terms of the US, where the mean wealth of a US baby boomer, there's 10,000 baby boomers retiring per day now, and about 40% of their expected future wealth consists of Social Security benefits, the expected present value. About 30% is net home equity, about 30% is financial and pension assets. And so the big questions we're concerned with is, how should we accumulate and decumulate in this new world, and where should we invest given such low returns? Moreover, because Social Security is such a big component of retirees' well-being, claiming Social Security turns out to be one of the most important financial decisions that households can make. And in addition, what we're interested in is the question of how state-organized deferred life annuities with complex claiming options could and should inform the financial behavior. So let's imagine that we had a world where the expected return was 3%. And let's imagine you had 40 years to claim, 40 years to save during that period. And if you had 40 years to save, you'd only have to save about 11% of your annual pay to reach a 50% replacement rate at retirement. because Social Security would cover roughly another 50%. If you started when you were 40 or 50 years old, then you'd have to save a lot more, even in a 3% return regime. But if you are living in a 1% expected return regime, you would have to save close to half of your salary if you were going to try to hit this 50% replacement rate target. And even if you have 40 years to go, you still have to save almost a quarter of your annual income. So this is the new world we're living in. So in this paper, what we do is build a model, a calibrated life cycle model for US households, taking into account much of the richness that we as real people face. Stock market uncertainty, uncertainty about labor market earnings. We don't know when we're going to die. We don't know exactly what our medical and housing costs will be. We have to model tax rules because, as we've heard about earlier from Professor Maurer, tax qualified rules apply to 401k defined contribution retirement plans. Tax rules apply to income, apply to Social Security contributions, and also we integrate real world Social Security benefit formulas. What we're interested in is this set of 5 different outcomes: saving and consumption, asset location, where do people save, inside or outside their tax qualified plans? What do they allocate their investments to, stocks versus bonds? What are their work hour patterns? And last but most importantly, I think, claiming of Social Security old age benefits. We do this taking into account a substantial amount of heterogeneity and institutional rules. So we divide our samples into males and females. We have projections of their life expectancies using life tables. And we've also created wage rate profiles for 6 groups, males and females, and within those, the least educated, high school dropouts, high school graduates, and people with college education and more. And so we actually estimate the impact of permanent and transitory shocks from the panel study of income dynamics. We also put a lot of effort into integrating the real detail for Social Security and Medicare payroll taxes, income taxes on labor income, investment returns, and retirement payouts. So it's very institutionally accurate. And of course, the tax qualified EET structure for 401k accounts. So in the US at the moment, most people, if they have defined contribution plans, do put their money in these these EET accounts. There's over $5 trillion in assets held by the workforce that has these. Typically, employees will put in before tax contributions. There's a cap of $18,000 a year, a little bit more after the age of 50, and many employers provide a matching contribution up to 5% of pay. The investment returns accumulate tax-free, and payouts from age 60 onwards are taxable. Up until very recently, there was a 10% penalty for early withdrawal, and required minimum distributions were mandatory after age 70 and a half. The 10% penalty has been relaxed, temporarily suspended, as have the required minimum distributions because of the COVID pandemic. Just a couple of notes about the US Social Security system. 95% of the workforce is covered. Social Security benefits depend on a nonlinear function of average lifetime earnings. So if you're a very low wage worker, you get a 90% replacement rate. If you have higher income, the marginal replacement rate is 32%. And if you're a very high worker, high paid worker, the marginal replacement rate is 15%. And you can claim under the current rules anywhere between age 62 and 70. But if you claim early, you get a reduction for early claiming prior to age 66 in our model. If you delay claiming after age 66, you get an increase. So the rules reward you for delayed claiming. And just to have a small picture of how this works, so if your claiming age is 62, you get only 75% of your primary insurance amount. If you claim 1 year later, you get 80%. So the boost to your benefits for the rest of your life is 6.67%. Now, if you waited to claim all the way until age 70, you would get 76% higher benefits per year for the remainder of your life. When these formulas were designed, these were roughly actuarially fair. So if you claim early or late, it doesn't cost the system in anticipation, but you do get a higher annuity the rest of your life. So our life cycle model, this is actually a similar picture to what Raymond Maurer talked about because it's a similar model. What we do is model wages, Social Security, financial assets, institutional rules. We develop a life cycle model and we ask what would be the optimal pattern for people to work, to save, to consume, and to claim, as well as invest during their lifetime. So here what we do is we look at 3 scenarios. The first scenario is what we call the old normal, the life before COVID, or even before the recent financial crisis. So in the 2% world, bonds would pay 2%, and stocks would pay a 5% risk premium with a volatility of 18%. In the new normal world, bonds pay 0 and stocks pay 5% risk premium, same volatility. And then we also have a third case, which we call the Japanese type case, where bonds pay 0, but you have much lower risk premium for stocks. And the first thing we do is solve the model for each of the 6 wage rate groups and simulate 100,000 optimal life cycles. We calibrate the preference parameters based on real data, which I'll show you in a second. And then we solve for other return scenarios and compare the behavioral outcomes. Fortunately, with some work, our calibrated model does a pretty good job replicating real world outcomes. So here on the left, you have the model data in the red bars and the empirical data in the blue bars. So what we can see is a lot of people claim at age 62 and a goodly number claim around 66. And then there's a fallback after that point. But we replicate the real data pretty well, which is an enormous accomplishment. And if we also look at the resulting 401k account values by age, the empirical data and our model data replicate pretty well. So that gives us some hope to be able to go further. Now, in this picture, what we show you is the asset totals in a 0% return world versus a 2% return world. So the new normal versus the old normal. And what we see here is that the tax qualified assets in 401k plans, this is for females, in the 2% world were quite a bit higher for all age groups than in the 0% world. So people saved more when they were rewarded more with higher returns. If you look in their non-qualified assets, there's not much difference in this for the women. But overall, since the qualified assets go down, total saving declines. And pretty much the same thing for men. Men tend to save less in the tax qualified asset and not too much different in the qualified plan. So overall, most people do save less when the return is 0. If you look at the average decline in 401k assets, comparing 0 versus the 2% return, the male college graduate saves about 40,000 less. The high school graduate about 30,000 less, and the high school dropout doesn't have a lot of savings to begin with, but definitely a fair amount less. And again, for women, you see declines in savings in 401k plans. If you look at the behavioral change due to the Social Security claiming ages, so in the top panel, we have results for women. In the old normal world, about 47% of the women claimed their benefits at 46, 47 years old. In the new normal, clearly you see much lower early claiming and much higher claiming overall. And in fact, in the so-called Japanese world, you see the highest average claiming ages of all. Similarly, for men, what you see is that fewer people take their benefits early, more people move later, and average claiming ages move quite a bit as well. So claiming ages go later and people work longer. The average delay in the Social Security claiming ages when there's a reduced return at 0 instead of 2%, about 12 months for the most educated men and women, and a smaller increase for the least educated. So you do see that the most educated would be most likely to keep working in a low return world. Lifetime hours worked per week, 2% versus real versus the Japanese scenario. Again, people tend to work longer and work more hours per week because their returns are substantially lower. So conclusions, we do see and we expect that people will save less in low return periods. Current COVID pandemic aside, because it's difficult to spend right now, people will finance consumption in this lower rate environment by drawing down their 401k assets sooner. They will delay claiming and they will work longer. And most importantly, for people interested in the tax qualified versus non-qualified pension accounts, people will save differently. When returns are low, workers will put less in their tax qualified accounts because they don't get as big a benefit from doing so, and they will put more outside their tax qualified accounts. So the implication from all this analysis is that having flexible retirement ages, allowing people to delay retirement and ideally giving them some incentive to do so, is very important in this new world that we're working in. So with that, I will stop and pass the mic on to Javier.
Thank you very much. This was perfect timekeeping as usual, to the second. Now, what I liked about the paper that you also distinguished the different income groups and the different wealth groups, and that's exactly something Javier is taking up. So I'm really looking forward to the distribution of pension wealth in Europe. Javier.
Okay, can you hear me well?
Yes.
Okay, thanks a lot for the invitation. Also, as Monika said, I am very happy to share the session with all of you three. You are very good scholars in pensions, so it's an honor for me. The presentation I will do today is a bit different from what we have seen before. I am going to describe more or less what is the distribution of pension wealth in Europe using a specific data set. This doesn't mean that we cannot do this with other kind of data sets. So I'm going to talk more about this in the presentation. So the main motivation to do this is to try to uncover and to have what is the role of inequalities in mortality or inequalities in life expectancy on inequalities on pension wealth. So this is the main idea of this paper, no? Is to understand to what extent the inequalities that we observe in mortality affect inequalities in pension wealth. By doing this, I am also between the agenda, the research about inequality on wealth. So there is a concept of augmented wealth that normally sum up private wealth or household wealth plus social security wealth, for example, or other types of wealth. So in this way, I also contributing to that literature. Here in this graph, I took this from an old paper I did with some co-authors. We used the Household Finance and Consumption Survey from 2010. So there are other waves. The last wave was just released last March. So it's a very interesting data set. So basically they measure wealth in many European countries, in the Eurozone countries. And here in the blue bars, I just plot the Gini of net wealth of the household. And then in the orange bars, I plot the Gini of augmented wealth. So this means private wealth plus pension wealth. So then you will see the inequality of wealth or augmented wealth is decreasing when I add this pension wealth. So in general, in all the countries, you will see a reduction of the inequality levels because pension systems in Europe tend to be more equalizing systems. So and this is why we will have a lower level of inequality in augmented wealth. So and then I was wondering what is driving this. So this is why I wanted to explore more deeply this question. So for that, I use mainly two data sets, two data sources. So first one is the European Union Statistics of Income and Living Conditions called SILC data. So this SILC data is used in all the European countries to measure living conditions, poverty, and many other important variables. And I use this data because also I have many countries in one data set. So one of the goals of this research is to compare across countries how is this inequality in pension wealth. So I used years 2006 and 2014. I had to make some selections. I have to use households that they have at least one pensioner there who is aged between 60 and 79. I did that because age is top coded, so I can now recover the age of people who is 80 years old or more or older. So then I got a sample size of 124,000 households in 2006 and 2014. So that data set will allow me to recover the value of pensions for the household and demographics. Then the second source is the data from the Wittgenstein Center of Demography and Global Human Capital. Let's call WIC data. This WIC data has very interesting data about the distribution of education in the world from 1970 to 2100, so projections, of course, by sex, country, educational levels, and also for the different years, for different calendar years. So I am going to use these data sets to recover mortality across different educational groups. For pension wealth, I am going to use just a typical formula. No? This is the equation number 3 in the slide. Is the multiplication of the pension, let's say P, times the annuity price A. This annuity price is just a number of monetary units I will need to finance one lifetime unit of pension. The annuity price, of course, is capturing the discount rate and also the mortality profiles across educational groups. So it's important also to clarify the concepts that SILC use for pensions. They have this classification of obligatory pensions and also private pensions or voluntary pensions. So obligatory pensions include many different systems, like pay-as-you-go, for example, or occupational plans. But the idea is that they are compulsory. And the other ones are voluntary and they are mostly private pension plan. So there is a big difference that perhaps is different from the concept that are using OECD and other institutions. Okay, then saying that, I compute the life table, as I say. So I recover the parameters of this WIC data to build different life tables for different educational groups, for people with education, for people with primary education and tertiary education. Also for different countries, cohorts, and sex. So that will be very useful to build the profile of mortality per education. I need to emphasize that I am using education as a variable capturing socioeconomic status. Of course, there could be other variables capturing this, like lifetime income, but I don't have such data. So I think it's a good proxy because there have been many works presenting evidence about a strong link between education and mortality. I am going to measure the inequality of the distribution of pension wealth with the Gini index because it's a kind of easy indicator to communicate. And then once I calculate a pension well for all the individuals according to their educational attainment, I will compare that pension well with a pension well computed without using this life table specific per age. So that will be the counterfactual distribution, and then I'm going to compare these two distributions and know what is the role of inequality in mortality on pension well. Here I present the results of doing this exercise. So in the first column, you will see the Gini index in 2006 when you don't include this mortality profile, this education mortality profile. And the second column is when you include, and the third column is the change, the percentage change in the Gini. So you will see many, in all the cases, there is a positive percentage. So that means that life expectancy inequality increase pension wealth inequality. Of course, this is an association. No, I cannot claim there is a causal effect, but that is homogeneous in all the countries. In all the countries, it's happening that. And in some countries, it are stronger than in others. For example, in Spain, the effect of this inequality in mortality is about 4.3%. So the Gini index of pension well increased by 4.3% because of the inequalities in mortality. The same will apply for 2014. So in all the countries, it's also positive as well, this effect. But the difference between the two is that in 2014, that change, that percentage change is lower. So this means that the role of this effect of inequality or mortality has reduced over time. Here I just plot what I have shown in the graphs. Then you will see that in 2014, there is a lower effect of this inequality of mortality on pension well. So this happens only in 3 countries, in Norway, Denmark, and Greece, and slightly in UK, Austria, Iceland, and Portugal. But in the others, there has been a decrease of the role of inequality and mortality on inequality of pension. Here, I also have had this question about, what about the private pension plans or voluntary pension? Those plans increase or decrease inequality? And more or less was obvious the answer, but I wanted to quantify this. No? Pension plans, private pension plans increase inequality in pensions. No? This is very strong in Spain and Sweden, both in 2006 and 2014. No? The explanation of this is because mostly people, richer people with higher incomes are the people getting this kind of plans. And also these people also are living longer. So the pension well of these persons is going to be higher, and so inequality in pension well will increase. In this table, this is just another way of analyzing inequality. So here I just decompose the source of inequality. Remember that pension well is the multiplication of the annuity price and the pension. So I can know what is the contribution of each element on the total inequality of pension well, and then I can compute a measure called the elasticity of the Gini index of pension well. This means in how much is going to increase the Gini when I increase 1% in the pensions. So and then I detect that the contribution of pension levels and pension inequality is positive, and also it has increased between 2014 and 2006. This means the contribution of the annuity price has reduced inequality. So this means inequality of mortality has reduced inequality in pension well. So it's the same as the other method I showed before. So the result hold. Then there is another method to see this. I don't know about the time. I didn't take into account, Monika. I don't know how many minutes.
Let me check. You have 4 more minutes.
Thanks a lot. Okay. Yeah. With this method, so there is a so-called risk regression or recentering influence functions. It's very interesting because you can know what is the effect of different predictors for explaining any type of inequality you want to explore. No? The idea is that for each person or each household in this case, you detect how much will influence a movement in the pension well on the total indicator of inequality. In this case, I use a Gini, but you could use any other thing, a percentile, the median, or other inequality measure. Conditional on the covariates that are not varying. Then once you discover these coordinates for each household, you regress just with linear regressions against some covariates, and then you detect the effect of different covariates on the inequality. So for these covariates, I use just age groups, household types. This is 4 types of households. We have the single male pensioner, single female pensioner, both spouses are pensioners, so in theory they are richer. Only one pensioner when only one person in the couple is a pensioner, and also 3 educational levels, primary, secondary, and tertiary. So the coefficient that you will get, you will read like an increase of 1% on X is associated with a change of Z% in the Gini index. This is just a typical curve of the influence function. So here is the case of Portugal in 2006. The blue curve is just giving the position of each household in the distribution of pension wealth. And the red circles are the household with tertiary education. So this will mean that households that are more into the right or more into the left have more power, more influence of inequality. But the households are more into the center, they are going to have less power over the inequality index. That was in 2006, this is in 2014. You can do this for all the cases. No? And then you will see that it's more compact. The circles went more to the center. So this means the effect, the inequality is going to decrease because of it. So because of the people with tertiary education. In the coefficient, so here I present only 3 countries. I will see the country where I am right now, Belgium. So in Belgium, you will see the coefficient of tertiary education in 2006 was 0.1. So this means if you increase the share of people with tertiary education in the country, the Gini will increase by 0.1% more in 2006. But in 2014, this increase is only 0.04%. So the power or the contribution of tertiary education has decreased between 2006 and 2014. And I found this in about 20 countries in Europe. So this also is in line with the other 2 methods that I presented before.
Javier, could you wrap up?
Yes. Yeah, this is the last graph.
Okay.
Here I just present the coefficients with 2006 and 2014 of this contribution of tertiary education, and then we see that the effect of tertiary education has decreased over time. Just to conclude, I wanted to show that there is a contribution of life expectancy inequality on pension wealth for sure, but I detect that this has fallen between 2006 and 2014. Also, there is a contribution of the voluntary pension plans. This increased wealth inequality as well. And that's it. So I hope I was on time. Sorry if I got more minutes. Thank you.
Thank you very much, Javier. That was very interesting. My own country is actually not on the list, but as a matter of fact, we made a similar computation, and in the end, it's a huge reduction of wealth inequality also in Switzerland. Good, thank you. Then we go to Brigitte. Happy to have you back on the pension conference, Brigitte. I'm really looking forward to your presentation.
Happy to be with all of you here today. So can everyone hear me?
Yep.
Okay, the title of my paper is Borrowing to Save, the Impact of Automatic Enrollment on Debt. And this is joint work with John Bashirs and David Laibson at Harvard, James Choi at Yale, and Bill Skimmyhorn, who is at William and Mary University. And we have to start off with a disclaimer because we're getting data from the US government. The views that we express are those of the authors and not of the United States Military Academy, the Department of the Army, the Department of Defense, the Social Security Administration, or any agency of the federal government, Harvard, Yale, BYU, College of William and Mary, or the NBER. Okay, so about 20 years ago, I started doing research on savings, and my first foray into this space was looking at the impact of automatic enrollment on retirement savings plan participation in the United States. And I looked at a company that had adopted automatic enrollment, and before they made this switch, the savings plan participation rate for employees who had recently joined the company was 37%. And if you looked at the data after the company adopted automatic enrollment, the savings plan participation rates went up to between 75 and 95% for every single demographic subgroup of employees in this company. And these results have been replicated in I don't know, thousands, tens of thousands, lots of organizations in the US and around the world. In the US, where I am, the fraction of voluntary employer savings plans that use automatic enrollment has increased dramatically from almost nothing to about half. This is data from Vanguard, one of the big administrators in the US. And the fraction of plans that have more than 80% of their employees participating has also increased dramatically as a result of this move to adopt automatic enrollment. This isn't confined to the US. A good example internationally would be the United Kingdom. They adopted a pension reform requiring firms to use automatic enrollment, and this was phased in between 2012 and 2017. The opt-out rate of employees in these firms is only 9 to 10%. And over the 6-year period from 2012 to 2018, they've seen a 32 percentage point increase in workplace savings plan participation. So this is a powerful tool to get people to save for retirement. But the big question is, where does the increased savings come from? If people are putting more money into their savings plan, what are they spending less on? So are they reducing consumption? And I think the goal of these efforts is to get people to reduce consumption today so that they have more money to consume in retirement. But that's not a given. They could simply reduce savings elsewhere. If they had other savings to reduce, the net effect on the balance sheet in that case would be zero. Or they could keep their consumption the same and simply increase their debt. And in that case, they've got more savings in one bucket and more debt in the other, and things might cancel out. So in this paper, we're going to look at to what extent is the increased saving induced by automatic enrollment offset by higher levels of debt. And to give you a quick preview of the results, we find that at 4 years of tenure, automatic enrollment increases cumulative savings in the savings plan we're looking at by about 4% of starting salary. It has no statistically significant effect on changes in debt that exclude auto loans and first mortgages. So think non-collateralized debt. In the US, the biggest source of that debt would be credit cards. The effect on auto loans and first mortgages is positive, but not statistically significant. So we find a point estimate that would suggest an increase in auto loan and first mortgage debt, but the data is fairly noisy and the standard errors on those estimates are large. And I'll talk at the end about some complications in how to interpret those results. So to answer this question, we're going to use data from the retirement savings plan that the US government provides to its employees. It's called the Thrift Savings Plan, and we'll refer to that as the TSP. And we're going to look specifically at government employees who are working as civilians for the US Army. And that's because that's where we could get the data. We would gladly use data on all employees of the federal government, but this was the subset of those employees for whom we had access. And the US government adopted automatic enrollment for civilian employees on August 1st of 2010. So before August 1st of 2010, if you wanted to participate in the thrift savings plan, you had to opt in. After August 1st of 2010, you were automatically enrolled unless you opted out, and you were enrolled at a contribution of 3%, and that money was put into a US Treasury fund, so a fairly conservative investment. They've since moved on to life cycle funds a few years later. The government also provides contributions to the retirement plan, a 1% non-contingent contribution given to everyone, and then they have a tiered match as well. So our data, we have two sources of data. From the US Department of Defense, we have payroll data for civilian employees of the Army from 2007 to 2015. Remember, automatic enrollment was adopted in 2010. So we've got data on both sides of that. And from the payroll data, we get your compensation, and we know how much you're contributing to the TSP, because that's a deduction from your paycheck. So we can infer whether or not you're participating, and we can infer your contribution rate. And then we also get employee demographics from the US Department of Defense. And to this data, we're going to merge information from a large credit bureau so that we have data that you would get from a credit record between 2007 and 2014. So we'll know what kind of debts you hold, if they're the types of debts that are reported to a credit bureau. We'll know how large they are. We'll know whether you're delinquent. We'll know whether you've filed for bankruptcy. We'll have a measure of your credit score, things like that. So our empirical strategy is going to be to compare outcomes, both savings outcomes in the retirement plan and debt outcomes for employees hired 1 year before automatic enrollment was adopted, and compare them to employees who were hired 1 year after automatic enrollment was adopted. We've also done the analysis using a regression discontinuity design with different bandwidths around the change, and we get qualitatively similar results. So I'm just going to present the more straightforward before and after comparison. This chart right here shows the demographic characteristics of the employees hired in the year before and the year after. Our sample sizes in the last row are fairly large, between 27 and 32,000 people. The credit scores and the fraction of people who have a credit report is strikingly similar across the two cohorts, as is the average age. The average starting salary is off by several $100s. It's a statistically significant difference because of the large sample size, but qualitatively, it's not a very large difference in magnitude, and we will control for things like salary in our analysis. The main outcomes we're going to look at are what happens to the savings that you've contributed to the thrift savings plan. Because we're using payroll data and not data from the savings plan itself, we don't have a perfect measure there, so we're just going to add up your total contributions to the plan over various time horizons. We don't observe withdrawals or loans or capital gains. The withdrawals and the loans are not going to be a big deal for this particular group. The capital gains are potentially more problematic. So you should view, I think you should view the measures on savings we have as a lower, probably a lower bound on the actual effect. We'll look at the credit score outcomes. We'll look at 3 measures of debt. The first will be non-collateralized debt. So that's your debt excluding the mortgage on your house and your auto debt. And we'll normalize debt by your first year pay. And then we'll look at auto loans separately, and we'll look at first mortgages separately. Once again, both normalized by your first year pay. So just to give you an idea of what the data looks like, this chart right here shows your cumulative contributions to the savings plan, your contributions plus your employer contributions by tenure, which is on the x-axis. For the cohort of employees hired in the year before automatic enrollment, you can see it goes up over time. It's going up pretty linearly, and that's because we don't have any capital gains. If we had capital gains, we'd see more volatility in those numbers, and we'd probably also see a little bit of exponential growth. And then here's the after automatic enrollment cohort, and you can see that their total contributions at each level of tenure are higher by about 2.5% after 1 year, 4.5% after 2 years, 5.5% after 3 years, and then 5.2% after 4 years. Here's the Vantage score data. So the Vantage score is a measure of your credit worthiness, and it ranges between, I think, 200 and 800. So it's got a pretty wide range, and you can see that it's increasing over time. That's what you'd expect as households are getting older. Their credit score generally improves. It looks like there are differences between the pre and the post cohort, and there are, but qualitatively they're extremely small. Here's our measure of non-collateralized debt over time. So the x-axis here is time. And the key thing I want you to know is there are clearly time effects here in this measure of debt. And automatic enrollment, and remember, is implemented in the middle of 2010. And the US economy is just, well, it's mired in the depths of the Great Recession then, just starting to come out. And that's going to be an important thing we're going to have to account for, is that the background characteristics of the economy are a little bit different for the before cohort and for the after cohort because of these time effects. This next chart, which looks at auto debt over time for both cohorts, I think really highlights the challenge empirically. So you can see this red vertical line is when automatic enrollment is implemented. And you can see in the 2 years leading up to this, auto debt for both of these groups is pretty flat. And then in the end of 2010, when the economy is starting to recover and financial institutions are easing up on credit, auto loans start going up. And if we for both groups, and if we were just to do a straightforward before and after comparison, here's the before cohort, here's the after cohort, we'd say, aha, auto debt goes up because of automatic enrollment, but in fact, it looks more like auto debt is just going up because there's a general trend in the economy towards increased auto debt. So I'll tell you in a minute how we try and account for that. Here's what first mortgage debt looks like. It's mostly just linearly increasing. So we're going to look at contributions, and then we're going to look at debt. And I'm not going to go into great detail about the empirical methodology, but the key thing is we need to take account of these time trends that are impacting debt outcomes. And the way we're going to do that is we're going to use other cohorts of employees that were hired more than a year before or more than a year after automatic enrollment, and use their experiences in the credit market to pin down the time effects that are going on in the economy. And we're going to control for time effects, for tenure effects, salary, age, gender, a whole bunch of other demographics. So if we look at the impact on cumulative contributions, on the x-axis, you can see the effect on different tenure buckets, and I've highlighted the effect that you get about 4 years out. We get an increase in total contributions to the TSP of about 4.1%. If we look at the impact on credit outcomes, The impact on credit scores is close to zero and precisely estimated. So there's no evidence that encouraging people to save more creates financial stress on households. If we look at non-collateralized debt, so debt excluding auto loans and mortgages, the point estimate is, for most of these 10-year buckets, is actually negative and fairly precisely estimated and small. So our conclusion here is there's no impact on non-collateralized debt. People aren't spending more on their credit cards to make up for the fact that they're now saving more in the retirement plan. If we look at auto debt, you can see the effects initially are small and fairly precisely estimated, but as we go out longer time horizons, they start to get a little bit bigger. 4 years out, it's a 1% increase in auto debt, and the standard error bands barely include zero in there. And then if we look at mortgage debt, much more volatility or much more imprecision in the measures. 4 years out, the point estimate is a 2.2% increase. Statistically, it's not different than zero, but we can't rule out potentially a large effect because the standard errors are so large. I think the big caveat on thinking about the impact of automatic enrollment on auto and first mortgage debt is that if we're using debt for a collateralized asset, when your debt is going up, on the other side, you're also acquiring an asset. So if you took on more debt to acquire an asset that had higher value, there's no impact on your net worth. We're only seeing the debt side. We don't see the value of the asset. So a larger secured loan could imply that you had a more valuable asset that was purchased, or that you had spent down less of your other assets to secure this purchase. And this could be plausible because if you had more balances in the TSP, a bank might be more willing to let you borrow more money. So the story's not crazy that that could happen. But things are complicated for auto loans and mortgages. Cars depreciate, as do homes. So even if you're buying a more expensive asset, you might then have more depreciation in the future. With homes, on the other hand, homes tend to appreciate in value, and you've got a forced savings mechanism. So it's really complicated to know how to assess the results on auto loans and mortgages. So our conclusions at the end of the day: at 4 years of tenure, automatic enrollment increases cumulative employee plus employer contributions by about 4% relative to your average first year starting salary. No evidence of increased financial distress as measured by your credit score or by debt that's been sent to collections. I didn't show you those results. There's a small decrease in non-collateralized debt excluding auto loans and first mortgages, but it's not statistically significant. So it doesn't appear that households are financing their increased savings by putting more money on their credit cards. Some evidence that auto loans and first mortgages may increase. The standard errors are large around those positive point estimates, so hard to know exactly what they mean. Even if it is positive and significant, it would be hard to interpret these effects on net worth because we don't see the value of the assets that households are actually purchasing. We just see the debt that they're taking out. And I think the results here really highlight the value of viewing multiple portions, if not the entire household balance sheet, and doing research on savings and other financial outcomes relevant to households. Thank you.
Thank you very much. That was very interesting.